Alright boys, pretty simple today. We're doing division revision. So we're going over stuff that we should already know, but some of us might need a little bit of a reminder, jog that old memory bank from last year and years gone by too. So when we're talking about division, there's a couple of things we definitely need to keep in our minds. I'm going to focus mainly on using the algorithm, and then we can talk about different strategies that we covered last year as we go on. So one of the simple things to remember about division is just it's the reverse of multiplication. So if we were doing multiplication and we did 7 multiplied by 4, we should all know pretty quickly that that is 28. If we flip that or inverse it and turn it around, that means we should be able to confidently say that 28 divided by 4 is 7, or vice versa, 28 divided by 7 is 4. So again, if you're pretty confident with your multiplication and you know your times tables, division should be pretty easy. So let's go straight into an algorithm. You can see I've set out 375 divided by 5 in my formal division algorithm. It looks like this in your books as well. If you're drawing in your grid book, just make sure you're setting out place value perfectly and you've got the algorithm perfectly lined up here. So let's go through and work it out, shall we? We're dividing 375 by 5, and as always, we would start trying to divide our hundreds. So we'd ask ourselves 3 divided by 5, and we know that that doesn't really go evenly. So I would put a nice big 0 up in my hundreds column. And now this is the step where I found people get most confused. We're not done with this 3 in the hundreds column yet because we haven't done anything with it yet. So now we need to look at this number as a whole. So we've got 37. And then we ask ourselves, how many times will 5 go into 37? And that's when you just run through your times tables in your head. So I know 5 6s are 30, 5 7s are 35, 5 8s are 40, which is too many. So we're going to say that that will go 7 times. And in our algorithms, we can do long division if we want, but I'm going to focus on the short division algorithm for now. So because I've done 5 into 37 will go 7 times, which is 35, I've got 2 10s remaining. So I'm going to go and just chuck them next to my ones column there. And now I'm left with 25, and I'm going to ask myself, 5 are going to 25 5 times, because 5 times 5 is 25, and I've conveniently got no remainders. So this is using the formal division algorithm to prove that 375 divided by 5 is 75. So in a problem-solving context, this question would be considered like a familiar type of question because it's pretty simple. All that you really need to do is pick out the numbers and work out what to divide by. So it says 8 people can be seated at a table. How many tables are needed for 263 people? And I know that I'm going to find out the answer to that if I chuck in an algorithm 263 and I divide by 8 people. So once you've done that, that is really the hard bit because now we're just going through and dividing. So we're going to start with our 2s. 8 will not go into 2. So we're going to put a 0 up here. Then, whoa, that's not a 0. 0. Then we look at our whole number. We've got 26 10s now that we're trying to divide by 8. 8 will go into 26 3 times, which is 24, which means we've got 2 remainders. 2 10s remaining. Put them in the ones. Now we're looking at 23 ones. How many times will 8 go into 23? It'll go twice. And then the remainder that's going to be left over there is 8 times 2 is 16. So it's going to be remainder. Oh, my brain ain't working so good. Remainder 7. So it's pretty close to going evenly, but it didn't this time. So some people stop their working out like this and they say, well, that's easy. The answer is 32, remainder 7. But that doesn't answer our question because the question says how many tables are needed. So we know that in this instance, we're going to have to round up because these 7 guys that are left over, they're going to need a table as well. So our answer is going to be 33 tables. 33 tables are needed because we can't just have 32 with 7 blokes standing around. So answer 33 tables. Make sure when you're doing some problem solving ones, you're thinking, do you need to round up to make sure you've answered the question? This question was, how many tables?